On behalf of InSpace, I welcome all of you and all the panelists there on the dais. Further, I request Dr. Vinod Kumar, Director Promotion, Indian National Space Promotion and Authorization Center, Sessions Chair and the moderator to kindly deliver his keynote address and the opening remarks. Over to you, sir.
Thank you, Burjesh. And very good morning to all the panelists, distinguished panelists, and my friends in the audience. I once again welcome, along with Mr. Burjesh, to all of you to this unique session, Beyond Earth, how AI is powering new era of space exploration and space applications. So it covers entire gamut of space here today, where all AI you can work with, or where AI is helping presently and we plan to do, or space ecosystem plans to do in the future. Friends, today we stand here in February 2026. The final frontier is no longer the destination of human bravery. It has become the ultimate test bed for artificial intelligence. We have moved past the era where satellites were mere bent pipes, means they were reflecting the waves to Earth. Today we are witnessing the birth of real cognitive space intelligence architecture. From India's Vyomitra, which is currently redefining human-robot synergy in the Gaganyaan program of ISRO, to the three-body computing constellations now processing AI models in near real time above our heads, the synergy between silicon and space has never been stronger. We are here today to discuss how AI is not just an assistant to astronaut, but a critical enabler of mission survival, where it is through autonomous robotics, edge-driven navigation, or even sustaining life through AI-powered space, agri-tech, or applications. Our objective here today is to map the trajectory of this revolution. I look forward to the insights of our esteemed panelists as we explore how we are building an intelligent bridge to the stars. Before we proceed to the session, we have one surprise announcement for our new space ecosystem. That is, we are having a seed fund scheme. In that scheme, we provide the grants up to 1 crore to each startup. So we have come out with a scheme where AI-inspired opportunities in the space sector. We are announcing this scheme. So I hereby declare this scheme as open for participation to all of you. So this is very insightful, and we have thought it over. We have more vertical and we have scaled it up further. We are seeking application as AI in space, space for Earth, smart access to space, any area you think. We will evaluate these applications through an expert panel, and we will disperse the grant in a time-bound manner. Just to tell you that we have already dispersed or approval for discussed 11. 7 is already working, 4 are under disbursement. So with this 6 more we have planned here, I request all of you to please participate in this enthusiastically. Now coming back to the panel, we have an amazing panel here on stage, which consists of like AI-powered Vyomitra. The developer of AI-powered Vyomitra, Mr. Durai Raj, is here. AI-powered Moon and Mars landing. You know, generally conventional methods are involved designing a mathematical model, that power descent phase using polynomials. We call it 15 minutes of terror, right? So we have the people, those who have simplified with the help of AI, how to land on Moon and Mars, Ms. Deepti, Professor Deepti Patil. Edge computing is very important. There are a lot of data which we are having. So there is the edge computing expert from high space, Mr. Vinay. Then we have space applications is very important, whether agri-AI or any applications, how AI is helping to find the insights into the data. Because you will not understand what is space data. But we have with us Ms. Jagriti Dabas, who is the CEO founder of Arms for AI. So she will be speaking on how applications, insights can be seen by a common man. It's very important. We have expert from Space Application Center, Ahmedabad, Mr. Astosh ji. He's expert in remote sensing, data processing and all. We'll have very insightful discussions how AI is helping in analyzing and decoding the data. And very important, last but not the least, Ms. Ista Ganju, senior scientist at ISRO. She has been working on guidance, navigation and control. My colleague, she has been working on autonomous missions, autonomy for spacecraft. How, the response time is in seconds. If you are getting signal from moon is 385,000 kilometers, it will take more than 1 minute for signal to come, 1 second. If you see here, the response time is also in milliseconds sometimes. How all these things are being incorporated in our missions in the space sector, how they are helping, we'll discuss, take insights from her on this. So these are the, I will say, the future AI scientists. They are living at the intersection of rocket science and artificial intelligence and neural network. Without further ado, let's bring our expert panel to discuss how AI is ensuring when we go beyond Earth, we don't just survive, but we thrive. With this, I will start my panel discussion. First, the very important, which nation is waiting, how AI-powered Vyomatra will steer our Gaganyaan mission. So, Mr. Durairas, welcome to this panel. And as we enter this new era of space exploration, how is the integration of AI-powered space robotics like the Vyomitra humanoid transforming your approach to space exploration? Over to you.
Thank you, sir. Distinguished guests, AI visionaries, very good morning and warm welcome to this wonderful session on AI, how AI is going to revolutionize the space industry in space exploration. So, as sir told, I'm from ISRO, developing the, leading the space robotics activity at ISRO. So, to start with, the ISRO's first unmanned Gaganyaan mission, so we are going to send a half humanoid, Vyomitra. So, it is a 35 degree of freedom system. It is not simply a machine basically. So, it is almost like going to mimic the crew activity inside the crew module. So, a lot of AI engines are put in with respect to the speech engine or visual cognitive features. All those things have been incorporated. Just to say some few points with respect to humanoid. So, in the launch phase itself, during the ascent phase itself, as astronauts are going to see the display panel, so this Vyomitra also is going to read the display and evaluate the performance of the systems, several parameters, dynamic parameters, and it is going to report through voice. And also after reaching the orbit, it is going to perform a microgravity manipulation. So it will be constantly keep in touch with the mission control room, takes commands, voice commands, and act accordingly. And more than that, if you see the Vyomitra, the major challenge what we are seeing right now is implementing the AI feature into that. To what extent? So there are certain limitations. If you talk about the data sets, the space domain training data set, it's a complex system. So we are going to have a digital twin and do the transfer learning. This is one area. Another one is we don't have any kind of luxury of having a data center or cloud or internet connectivity. So we need to have a edge computing, right? So that's what we are trying to attempt. So even though it is a precursor mission for future human space programs, if you look at, so we are going to have a Bharatiya Antarikshya space station. So we are going to have a lot of space robotic systems. It is going to autonomously operate several systems, right? So if you talk about the robotic manipulator, either robotic manipulator or free flyer assistants. So when you talk about the free flying assistants, it is not simply going to perform tasks inside the space station. So it is going to assist the astronauts, and also as going to be a companion robot. So for doing all those things, we need to have a, the edge computing platform and a different approach, probably implementing the SNN, that is a spiking neural network in the FPGA platform. So that is a challenge. So that's what we are also going to do that.
To reduce your complexity, we have edge expert probably.
Yeah. So probably
later.
Vinay will be covering
Thank you
more
for,
than that.
Yeah,
one last point, sir. Actually, the integration of AI, it is into the system, such a kind of systems. It's not simply an upgrade. Okay. So it is a backbone of our vision, space vision 2047, Viksit Gaurav.
Very interesting. You have told 35 degrees of freedom. We have worked on 6 degrees of freedom. We can understand how difficult it is to do. But yes, AI is making it possible. We'll continue with this to our next distinguished speaker, Dr. Deepti Patil, Dean at MKKS, Cummins College of Engineering. Madam, you have worked with us on autonomous landing on Moon and Mars, and nicely you have mimicked it on a drone to see the hazard detection and land on the surface. You see, what are the hardest technical challenges in making such kind of landing? Because the panelist sitting next to you works on mathematical models, coding those things, first mathematical formulation, making polynomials, compute time to go, and you simply did it by using artificial intelligence. Can you just throw some light to our audience?
Yes, sir. Thank you for the question, and good morning, everyone. I have worked on the autonomous lunar landing problem statement. We are mainly working on the soft landing in a power descent mode. And I could say, working on this problem statement, the hardest challenge is taking the real-time decision in an uncertain environment. So if we consider the lunar terrain is very unstructured, and it is an uneven. There are various different hazards, let's say craters, boulders. There are extreme lighting conditions. And when we want to train AI models, mainly AI model training requires a data. So with the limited data availability, if we can autonomously train our AI models, where different trajectories are given to the models, and that can be tested in a simulated environment. So the solution which we found out is modeling the entire lunar in a simulated environments where there are various types of Apollo landing sites that can be modeled, and on that, on those sites, the spacecraft will be trained for safe landing. So here there is a convergence of AI and AR/VR techniques, where we can have the blend. The models are being trained with these safe landing trajectories first, and then that can be validated for actual lunar missions. So real-time decision makings, when we are talking about, it is not just identifying the hazards, but taking the real-time actions, let's say thrust control, generating the controlling command, thrust control commands, or changing the trajectories, and that too in a resource-constrained environment, because there are computing power limitations. The response time is also one of the key factor, where there is any kind of human control or human intervention, and you have to have the engine has to take that action autonomously. So it should be really accurate. So that actually there is a challenge, but AI can help us to learn the things without knowing the planetary conditions. It may be the case study, may be the lunar, but it can be applicable to other missions also, let's say Mars, as Sir said. So the atmospheric conditions may change, but if we simulate environment in that particular simulator environment, it will help us to find out or we can say increase the success of the planetary mission.
Excellent, madam. That's so nice, because what we were getting initially difficulty in getting the data of lunar surface. Then they simulated that data also. That's what AI can do. And then we searched, by the time we found the data somewhere, and we tested it. the one unique thing which they did is they painted on the ground lunar surface and used the drone to land with a hazardous this thing, and that quadcopter drone landed safely.
Yeah.
Excellent. We'll come back further how the natural language processing is helping. Now both of the speakers has discussed on edge computing. So we have another very good founder and CEO of SkySir, Mr. Vinay Sima. But there is a lot of both the speakers has told that what is the power of edge computing. So I will teach how can AI models accuracy be achieved at the edge, because it's very important. Accuracy is everything in space missions. So how you will achieve this? And does not running AI models on edge consumes more power for computation? How it is being managed? So over to you, Mr. Vinay.
Thank you for the question, sir. Thank you for having us here. And thank you, audience, for being a part of the session. Largely, going back, SkyServe has been the frontier of Edge AI for the last 7 years now. And we have completed about 5+ missions and doing about 15, 16 more in the next 12 months. So going back to the models, as we all know, geospatial models are power and compute heavy. They are not designed to run on spacecrafts at all, and the trade-offs are very huge. And these are 300 MB, 500 MB, or even some of them are 800 MB models, which consume a lot of them. And when you do a trade-off on a specific sensor data with various spectral bands, that does cause an issue for accuracy or the outcome of it. So what we do is we have deployed a system on ground which enables a geospatial model to become a geo AI model to tune it. Let's say it's a 300 MB model, it becomes a 30 MB geo AI model, which is tested across various parameters for a targeted spacecraft. And then after testing through various phases and processing it to the level that's desired for the customer's perspective. And then when it's checked and revalidated with the system on ground, that's when we push it up onto our system on board the satellite itself, so that further on our environment on board the satellite, it does not draw too much power, it does not hamper on the accuracy of it, and it functions in a seamless manner, sir.
Excellent. So that's very important. He is reducing probably what kind of data reduction you are able to achieve. Just one number.
So largely, we do 10x reduction. We are 10x faster, 5x by reduction size, and probably 3x more affordable.
MB data, MBs of data you will bring to KBs or
yes,
something?
sir. We broadly call this as insights as a service, from space directly to the device or directly to the earth. In a few kilobytes, the customer has an option to either pick the raw scene that's most favorable to them, or what we call as an image chip, and prior to that an insight itself. So insights come in a few seconds or minutes based on the connectivity at the backhaul, and then the image chip comes in, and then followed by the imagery itself, sir.
Excellent. Yeah, it makes sense to reduce the data, and it will further easy the things without losing the originality of the information. The next very important thing is, I'll move on to Mr. Asutosh Gupta, expert from Space Application Center, who has been a nodal center in developing application in the space sector. Mr. Asutosh ji, for generations, farmers have relied on institutional and traditional calendars. Right? You start olden days with the 2026 rollout of Mosam GPT and local AI advisories that predict hyperlocal weather and pest outbreak more than a week in advance. Are we finally seeing the end of agriculture uncertainty, or does this create a new risk of technological over-reliance if the data is off? Your views on that?
Thank you, and that's an excellent question, and thank you for having me on the panel. So what I feel is it is very important to have the right perspective here when we are talking about technological advancements. So there is a traditional model which farmers have
rights, but it comes from careful design. And I would also go on to say that in the recent complex missions that we have had, like lunar soft landing missions, where there were a lot of non-linearities involved in the environment, in the dynamics, in the actuators, we did use mathematical tools like optimization and regression to automate a lot of the landing sequence and retargeting of the landing site. So I would say that we are definitely using the mathematical tools like optimization and regression, which are like precursors to AI. They are the foundation on which AI is built. So I think we are definitely to some extent, we can say that it's not the full-blown AI as we see it today, but definitely there is an element of AI in our designs. Coming to full autonomy, whether it's a requirement or not. So as we talk about going beyond Earth, as we talk about deep space exploration, let's say we talk about the Mars mission, where like sir pointed out, where the latency in communication is in minutes actually. It can be up to 20 minutes. So by the time a command from the Earth reaches the spacecraft, it's already outdated. So keeping that in view, I think we definitely have a need for more and more autonomy. Having said that, there is a strong concern about reliability of the AI systems. While I'm sure that it will and it does bring down the time and cost that's put into the design, it brings it down substantially because you can iterate through a lot of configurations and a lot of conditions quite fast. You can run very quick optimizations, and so it gives you like a quicker prototyping capability. But having said that, as a control engineer myself, what we talk about more is like stability. What we're concerned about is guarantees in the system. So if my system performs in a certain way, it behaves in a certain way, I would like to know what input signals caused it to behave that way. Is it repeatable? So I want explainability in the AI systems or the autonomy, whichever way I build it into the system. Additionally, I also wanted to work in like under uncertainties. So I do want to have the aspect of robustness. So I feel fully autonomous satellite is feasible, but there are some challenges, and of course the compute, which Mr. Vinay is trying to address, and again the availability of data, like ma'am said. So there are some challenges. So I think it's feasible, but it's like somewhere close.
So you are giving academicians further work to do. So they should work on, they should explain the performance. Yeah, I remember when we first built up autonomy in ISRO satellites, rather it was on the demand from a customer from Eutelsat that I want 48-hour autonomy. Our satellite didn't have, always human in loop. They wanted in your control center, there should be one person. We removed all people, how we are managing manually. But then we incorporated this, and it was a great learning. When we did map all the system performance, put the surveillance on each subsystem, sensors, actuator, if this will happen, we will do this. And we know how much hard you have to explain to them when. And I'm sure you will have tough time to incorporate AI fully. And I'm sure that our team from Vyomitra will be facing all these things. Excellent. We'll take the new round, maybe rapid fire. We have Mr. 25 minutes. We'll continue the discussions. Mr. Durairas, we have another question to you. What is the ISRO's broader roadmap for AI-powered autonomous systems in India's future space missiles?
Yes, sir. Yeah. So with respect to roadmap, if you see, our roadmap is very clear actually. So we have two verticals. One is the developing the sophisticated space robotic systems for future needs, especially when it comes to a human space mission, or it can be interplanetary or lunar sample return missions. We are going to develop several robotic systems. That is one vertical. Parallelly, we are going to develop our own AI models. So that is it is basically a compact model, space-specific models. So this is another parallel vertical we have taken up. So coming to the robotic systems, if you see, currently the Humanoid Vyomitra is going to fly in the first Gaganyaan unmanned mission, and subsequently we are going to have the robotic manipulator for our space station, Bharatiya Antarikshya Space Station. So one is for the internal robotic manipulator, which can handle the cargo internally and can perform the scientific experiments, microgravity robotic experiments autonomously and going to have a free flying robotic assistant. So it is basically a, it can move around the station and do a predictive health management system and take care of the entire space station health monitoring, everything. And once the human presence is there, it is going to assist the astronauts and also be a companion robot. That is another activity we have taken up at ISRO. Then the third one is developing a full-fledged humanoid, which is fully autonomous AI-powered system. So the first Vyomitra is basically it's a precursor, and as a technology demonstrator, we have been flying it. So subsequently, we are going to have a complex system.
Excellent.
Yeah, thank
so
you.
we used to hear how Canadian arm is working on International Space Station. So we will have Indian arm on in space station. That's very interesting insights you are giving. I will slightly change the sequence. Now I will move on to Mrs. Taganju with a question, very general question. Now, as you know that from your vantage point, what advice would you give someone entering the space sector today? Because some of the youngsters might be watching. Should young engineers entering the space sector focus on only AI, ML or mathematical fundamentals, physics, part of it? What is your views on that? What they should focus?
Sir, like Vinay was earlier pointing out, and Jagriti as well, that the barrier to entry has been lowered a lot by the AI systems that we have today. But having said that, I believe if you give a tough problem even to one of these AI models, they will give you a solution. But to understand whether that solution is right for your application, to be able to judge the solution properly, you need to have very strong fundamentals. And be it any discipline, be it space systems or be it any other discipline, I think the fundamentals have to be strong. And I also believe that there's a saying that asking the right questions is tougher than answering the questions. So I believe that if you have the right fundamentals, you can ask the right questions to the AI and get much more out of it than perhaps a layman or perhaps someone having a very superficial knowledge of the system. So I believe that's something which is very important. And I feel that due to AI coming into picture, the gap between someone who has a good knowledge of fundamentals and someone who doesn't is going to only increase, because people who have a good knowledge will do, I feel, 10x better than someone with AI assisting them as compared to the other people. And one more thing I would like to add is that in addition to definitely the fundamentals, you should also be, I think, well versed with the data-driven techniques in your field. Like in controls, we have data-driven controls, and if you are in a mathematical field, it would be good to have a good knowledge of statistics and the techniques associated with that. And on top of that, I think the most required skill for any person in any discipline would be the ability to adapt, because we do not know what kind of developments the AI system is going to undergo in the coming years. So we should have the ability to adapt to the new ways and be able to learn and unlearn as we go.
So very interesting thing. She's again re-emphasizing the explainability and robustness. Yeah. Because we know that when we design a control system, we are given your gain margin should be this much, your phase margin should be this much. Otherwise, you will give a command, if it is phase is 90 degrees, so it will act after your 90 degrees.
So can I add one more point?
Yes, please.
So sir was earlier asking me about reliability. So I feel even if we design like AI-based autonomous systems, I think we will have to put in a lot more effort in the testing and validation as well of these algorithms. And I think these validations should be physics-informed and physics-based. So I think we cannot really say that fundamentals are taking a backseat today in any way. So I think...
physics-informed matter, very important. Yes. But same perspective, this is an industry perspective. I'll transfer this question to Dr. Deepthi Patil, academicians. A lot of research work she has suggested you. Previous question also and here also. Yeah. Your take on this?
Yes. I would like to add with ma'am that she said about physics informed, whatever autonomous landing, it should be physics informed. So now there is new concept of physics informed neural networks. So
okay.
PINN. Those kind of networks are being trained so that we can have that fundamentals also as a base to validate whatever autonomous systems are being built. So for example, reinforcement learning is being used. So there is a policy decisions, and based on that the rewards are given. So those policies can be physics informed.
Yes.
So that we can validate that particular system whether it is correctly working or not. In addition to that, you asked one of the questions, that is how you will give like youngsters. Being an academician, I interact with different students, and I could see that they are very fascinated about space. When the name of ISRO, when name of NASA comes, they are very fascinated, and they approach. As I am working in space technology. Ours is an engineering college, and it doesn't have a full-fledged space technology course, but still they are interested in developing the system, learning the systems. So in this case, I could say that students are coming from multidisciplinary. So space technology is also a multidisciplinary area. Not only a single domain is applicable. So where there is a coding, we can have AI, IT and computers. When there is a communication, we have electronics, mechanical for rocketry. So fundamentals are very much important, and it should be there for validation of the system. But it should not be a rework. So instead of that, if the multidisciplinary team can be formed, so it will be reduce the time of learning, and they can devote their time in developing.
Yeah, very
so
important.
That
very
is
important
the main thing, that otherwise the person who is not from that domain will spend more time on learning the things, and maybe that may discourage that because that is not their domain.
Yeah,
but where they can contribute, the youngsters should focus on that. One more thing is, like initially when these engineering students or youngsters, they see that what kind of packages they are getting. So placements is also very important for those youngsters. So now because of this space sector has opened up, now it is not restricted only for ISRO, and many startups are coming up. The job opportunities are also created, and that is the main thing where students are now, or youngsters are now interested to contribute, and this will also help to develop the technology with young minds.
Yes,
so that is
good.
my opinion.
Thank you for your insight. But explainability and robustness point is of a control engineer. You have to take into mind.
Yeah. So
Okay.
explainable AI is very much important.
Yeah.
So decisions has to be backed up by the explainability.
Then I will throw you another question which
Okay.
other panelist has been asking, is that how natural language processing is evolving to help humanize conversation for a space assistant, right?
Yeah.
Or a assistant. Or, yeah,
So
yeah.
as Duraj sir said about that, humanoid should not be just an assistant, but it should be a companion. So when you are talking about companionship, then there should be a human touch in the humanoid. So when you want to have that type of human touch, the natural language is the more impactful factor while conversing. You can see that there is LLMs are there, DeepMind is there. So these transformer models are already there, which are been generating the text-based responses. But if you want to have that type of human level language conversation, it should be based on the speech-based techniques, where not only the text but speech should be understood. The semantics are important. Context-based understanding. Context is very much important. So how we can embed this context-based natural language processing for the humanoid, this will make that particular humanoid as an companion to the astronaut impactful.
So you are telling this still it is evolving over
Yes,
the time.
yes.
Thank you for that. Now I'll move on to Mr. Vinay Shima. So, see, your edge computing, what kind of models are, in general case, models are updated on the ground constantly. How does edge evolves AI models get updated with shifting priorities or geopolitics? So your views on that.
Largely, as Ishita also mentioned, and Deepthi also mentioned, the fundamental shift is any mathematical model or edge model is also defined by the level of test cases that you're open to and certain level of scenarios. Hence, and your desired state is where, like, you'd update a phone application on your smartphone seamlessly as you over-the-air update. Is a similar feature possible on a smartphone as well, where it transitions to a smart satellite? So when we thought about this model and we started writing about it, we had to give hundreds of pages of warranties for some of the missions that we did, saying how would this model be updated on board? How would it factor geopolitical considerations or weather conditions or climate change, which is a reality, or disaster management or volcanic ash, which could create this? With roughly about 67% of Earth's atmosphere filled with clouds on an electro-optical mission, a bulk of the data is also not usable unless you're doing a cloud study. So having factored these, we started building an engine which says, just the way you're able to update your models on the phone, we should be able to, beyond the test cases, we should be also able to update these models on the go, on the system, on the ground, and so that we could do this patch updations and we could send it up as a telecommand to the system on board. It works like a yin and yang.
So here human is in the loop or automatically?
It's automatically done.
Good.
And of course, the parameters are again validated, tested to confirm the results are okay, and the parameters, because the weather conditions and ground realities keep shifting now almost every other day, not even a week. So we have to keep updating this, and that's a model that we have to build through, sir.
Thank you for those insights. I'll move on to Mr. Ashutosh Ji, where he has been expert in data processing. So what aspect of data processing and application is AI helping you address and solve better than traditional methods? That is the first. Also, what do you think is the most important aspect of AI when it comes to the remote sensing data processing? It can be one only, but I am giving you it in two parts. So your insights on that.
Oh, thank you. So the first part, I mean, when you look at the transition that has happened in terms of data processing, the kind of volumes that we are looking at, for example, if you look at the recently launched NISR, you have 85 terabytes of data per day. And that tells you something like in the next 5 years, the kind of data that we are going to have is going to surpass the kind of data we have collected for last 4 decades. So from this raw information that you're getting from these different sensors, different type of sensors, they are not just optical sensors, SAR sensors, drone platforms. So you're talking about multimodal data, raw data, which is not necessarily usable by the application users. So you have to convert that raw data. You have to get those details. You have to reduce the uncertainty into the, which is built into the data due to the design, the limitations. You have to bring out the quality in the data, essentially. And you have to measure that quality. And AI has been playing a big time role, and we are working on those models at ISRO. That is the primary objective with which we have been working on. Let me break into two parts rather. So the second part is that once you have these standardized and homogenized data from each of the sensors, what do we do with that? Right? So now you need to actually merge that information which is sitting in individual bins together to form stacks which can talk to each other. And this is the second place which I feel ISRO has been working really well towards, and we are trying to integrate all our sensors into a common platform, for example, Vedas and Bhuvan, where we can actually have all these layers which are accessible to the users, and we can provide insights through these users. So the AI has been a transformational power in that sense. Second part, which you asked actually is very important, that what is the most important factor? I would say the most important factor today is data. The models are definitely important, but any AI model is only as good as the data that they consume. So I would put my emphasis on really enlarging the kind of data sets, especially for the Indian regions and Indian use cases, and having not just the volume of data, but the quality and heterogeneity of the data. That's going to drive our AI revolution in this sector. In future, we are going to see a lot of shift toward complete autonomy when we are talking about planning the entire satellite fleet, and without us knowing, it will be able to observe and point our satellites to a location which is expected to see a change, and do that processing through edge computing and bringing it down for the ultimate decision making and actionable intelligence that can be brought through information layers.
Good, very
so
interesting.
Just to add one more point here, that foundational models, which are a big name today, you have to work, they work with a lot of data, so they consume a lot of data from different sources, but they are easily fine-tunable to our individual use cases. So the last 10 years have seen different models for different use cases, which was the kind of norm. So if you have detection, you will build one model. If you have classification and other things, you will build another model. But now we are seeing a large-scale integration of these models, so which we are working on at ISRO, and this is what I feel the future is going to be.
Very nice insight. The quality of data is important, and we say ethical AI is also very important nowadays. Well, otherwise, your all outcome will be of no use. That's why the Ista's point is very important. The explainability should be there, those features. I have very rapid fire round it is, so I'll move to Dr. Jagrati. Madam, can we build a future where farmers don't need to understand satellites complexity, AI complexity, can still clearly see how do smart agriculture or precision agriculture by saving water on cost on pesticides and other things, and they can earn extra income. So using space technology and AI. So your views on that in 1 minute, so that I want to have 1 or 2 questions from audience as well.
Yes,
Over
sir.
to you.
So it's a very interesting use case. We are an agrarian country. Everyone knows pesticides and agri advisories. These are very important to save the cost of cultivation. But there is a new concept. I would not say it's new, but it's an upcoming concept called carbon credits. Every landholder in India can generate an extra income just by doing the same thing that they have been doing since past 2-3 decades. And this carbon credits can be generated and sold to the giants to reduce the carbon, to get into the carbon neutrality concept that is emerging. And that is where space data and AI can actually help. And recently we have been working on this, that every day, just by sitting at your land, you can get to know how many carbon credits can be generated from 1 hectare land and how much income I can generate just by signing up on that. So this is where the AI and space data impact can be done, where every day you can get to know, today, am I reducing some emissions or no? And again, with no hassle, and that's how we have been all making an impact and talking about the natural language, conversation, no need for complexity, and just pure impact at a grassroots level and at scale. So this is a real impact, and that's where we are all working towards.
Excellent. Thank you for those insights. Really, you have brought the new concept of carbon credit. This is extra money. If you save water, if you save fertilization, save on that, you save on the input cost also, but you get additional carbon credits. It's a very good, interesting. I have 6.5 minutes more. I can take 2 audience questions today. Yeah. We'll start from here, gentlemen. Next to you. Yes, please.
First of all, thank you so much for great insight and having a nice panel over here. My question is more about AI accuracy and reliability in research and development purposes, and specifically for interdisciplinary uses. I, being an architect, I'm more of thinking of how I can use such data and use AI as an enhancer to it. So my question again would be to Ma'am Ishita and Ma'am Deepti and Ma'am Jagrati as well.
Okay, Ishita, you can take this question.
Sure. So, if I understand your question correctly, you're talking about reliability about the AI models.
And accuracy of data. Data accuracy, right?
Data accuracy?
So, it's about the accuracy, how the data that is perceived is correctly perceived to me as well, who doesn't have much knowledge about how the data is processed at the first point itself.
Right. So, I'll answer the question about reliability first. So I believe that, to make sure that the AI performs in a reliable way, I think at present what we can do is like verify and validate rigorously. That's the only method, like do Monte Carlo analysis, simulate all non-nominal conditions, and see if, that statistically you are within some good bounds, like your success rate is enough to give you confidence that you can go ahead with the mission. That's about space. And similarly, maybe since you are an architect, I don't know much about that field, but like there may be things like you are like probably concerned about the structural integrity of your structures and such, mechanical aspects of it. So I think even there you can use like some sort of an simulation environment where you can simulate some sort of non-nominal conditions, maybe earthquakes or whatever is right for your domain. So that way you can check whether the outputs are reliable or not. And the second thing would be to, for you, since you are the domain expert, for you to have a checklist. Maybe you can take help of AI itself to even prepare that checklist and make sure that all of the critical aspects that need to be met are getting checked. All the check boxes are, ticked. So that's one thing.
Yeah.
And for data processing, I think...
One more question we will have. I'll transfer it to Astoshi also. Actually, she has brought the concept of Monte Carlo, where billions of simulations are done, with considering all 3 sigma variations of worst case this thing. That will tell where your system, where the model which is there, whether it is robust enough. So that is the purpose of her saying that Monte Carlo thing.
So data augmentation is also one of the way. Data augmentation is one of the way where we can have the variety and then again testing on that. So
we'll
adding
go to next question. Brief answer to this.
Just one point I wanted to add is like, when automating any new field, it is very important to digitize, or if there is any digitized data already available in your field, that can act as a validation. Which of the previous designs have really worked well, which haven't, and due to what reasons? If you can pass them to your new models and get similar kind of results, then you have validated them in the proper way.
Yeah. Thank you for that quick answer to his question. But many hands are there. Okay, quickly we will say.
Yeah, Dr. Vinod, you yourself bring expertise of GNC systems from your past work. So between you and Dr. Durai Raj, if you could help us understand the developments on onboard autonomy for collision avoidance as it's happening, as we foresee ahead. Just one more question. With respect to remote autonomous systems, while we are looking at precision and accuracy, are we able to leverage backward propagation or is there a challenge when we do that in terms of responsiveness? So that's for you, Dr. Ishta.
I will give a very brief. For collision avoidance, Netra project of ISRO is working on that. We have worked. Rendezvous docking, you have seen how precisely 7 km per second, 2 spacecraft we have docked there. So we have all those capabilities. Many algorithms on this are already in way. So no worry, our eyes are open, algorithms are in place, everything will be taken care. I'll go to next question from backside somebody. Yes, sir. Aapka. Good interest. We may take 2-3 minutes extra, please. Organizers. Abhi 142 hai.
Hi, sir. This is Surendra Singh from Times of India.
Yes, sir.
So, ma'am talked about that it is feasible to have a fully autonomous satellite. So, just my question is whether ISRO or USRC is working on such fully autonomous satellite currently. Thank you.
So I would say that as of now, with each passing day, we are building more and more autonomy in our satellites as we go from mission to mission. So right now, I don't think although it is feasible, but we are going step by step in introducing autonomies in the system, and I don't think
I will tell this way, that we are taking very cautious approach, like we are using AI for hazard detection. In control, we are going mathematical formulation basis, but parallelly through AI also, we are learning how AI is performing. So background thing is going on. We are using AI at the ground where we can find out the faults with sensors. We are validating even thousands of solar cells and all. AI is being used, but yes, in mainstream, it will take some time.
Onboard, I think it will take some time, but on ground and to automate ground operations, it's already in use.
Thank you. Yeah. Thank you very much. So I will close this here. What is clear from this panel? Very good insights. So beyond Earth is no longer a distance measured in kilometers, but in milliseconds of latency and terabytes of local insights. The synergy between AI-powered robotics and autonomous mission control is creating a nervous system for our species as we reach into cosmos. However, as our panelists have noted, the power comes with responsibility, trust and governance. As we delegate mission-critical decisions to algorithms, we must ensure they reflect our highest value of safety, transparency, quality and international cooperation. I want to thank our all panelists and especially Mr. Brijesh Soni, who has put all the things together, for this complex orbit today, and to all of you audience who has made this really the next era of exploration. It won't be just about who has the biggest engines, but who has the smartest systems. That is the important. The frontier is open and it is intelligence. I now declare this session closed. Thank you very much for your time. Namaste. Jai Hind.